Here we go on Polynomial Functions 3.4. So these first ones, we're just doing some, basically some review from last year, solving for x. So, x squared minus 16 equals 0. First thing we want to do is get that x by itself. So we get x squared equals 16. And remember, the opposite of squaring is square root. So we take the square root, so we get x equals. Now, here's the tricky part. Some of you may just want to say 4 and be done with it. But if you can remember, that square says that we're going to have two answers. Okay? So we've got to think of it this way. Well, what's 4 squared? It does equal 16. Is there anything else squared that equals 16? Yeah, negative 4. Because of that nature of the squaring, when you take the square root, you're really thinking positive and negative 4. There's a positive 4 and a negative 4 that are part of your answer. Okay, for number 2, x squared plus 4x plus 3. So we've got to factor this. When we factor it down, we get x plus 1 and x plus 3. Then we separate each one of these and set them equal to 0 by themselves, and then solve for x. So we get x equals negative 3 and x equals negative 1. Okay, number 3. X squared minus 5x plus 6 equals 0. Same thing. Factor it down. We get x minus 6, x, oh no, x not minus 6. That one wouldn't work, would it? X minus 2, x minus 3. Set those separately equal to 0. And then solve for x. So we get x equals 2 and x equals 3. Okay? Now in number 4, what we'd do is we'd subtract this 12 from both sides to get x squared plus 4x minus 12 equals 0. Then we could factor it. And we get x plus 6 and x minus 2. Separately set them equal to 0. We get negative 6. And you should already be able to see the positive 2 there. So negative 6, positive 2. Now number 5 is pretty much almost already done. We just take each one of these pieces and set it equal to 0. So we get x equals negative 4. X equals positive 3. And x equals negative 1. Because that's 3 x's, right? That would be a cubic, and x cubed. We know we've got 3 x-intercepts, because that's what we're doing when we solve for x on these. We're finding the x-intercept, the root, the 0, as they're often called. Okay, number 6. First thing we got to do with these ones is we need to factor that. So we have x times, let's see, x minus 3, x minus 3. So each one we set equal to 0, so x equals 0. And then notice that's the same thing, so we just do the same thing twice, right? So we get x equals 3 twice. And there we go. Okay, now we're combining polynomials. So we've got f of x, we've got g of x. So we want to find f of x plus g of x. So I write f of x, x squared plus 3x plus 2, plus, then I write g of x, 5x minus 4. Then we combine like terms. There's no other x squared, so I write that one first, because we always want to get in the habit of writing that highest degree first. Then 3x and 5x would give us 8x, plus, then 2 minus 4 would be a negative 2. Or we could just write that minus 2. Same thing. And there we go. We've simplified it as far as we can. Do the same thing. F of x, x squared plus 3x plus 2. Now with minus, we're minusing the whole thing. So we're thinking of that whole thing as being subtracted. So you put it in parentheses, which means you then distribute that So we end up with x squared plus 3x plus 2 minus 5x plus 4. The negative gets applied to both pieces. Okay, so then no other x squareds, positive 3x, negative 5x, negative 2x, positive 2, positive 4 gives us positive 6. So even though we're adding and subtracting, we still come up with different answers. Okay, now same thing, f of x times g of x, so parentheses x squared plus 3x plus 2. When we're doing multiplication, we want to use those parentheses. Then we just distribute. So this x squared gets multiplied by both of those. So we end up with 5x squared times x would give us x cubed, right? We take their base powers and we add them. Okay. And then x squared minus 4 would be negative 4x squared. Then we do it with the middle term. 3x times 5x would give us 15x times x gives us x squared. 3x times negative 4, negative 12x. Then 2 times 5x gives us plus 10x. 2 times negative 4, negative 8. Now we do combine like terms. There's no other cubic term, so we go 5x cubed. And we've got negative 4x, positive 15x squared. So x squared we can combine, so that would be a plus 15 minus 4 would give us 11x squared. Then negative 12x plus 10x would give us a negative 2x, and then minus 8. And there's our answer. Okay, now we're going to take a look at them graphically. A lot of different ways that you could do this. One way would be to do what we just did and combine the functions and then graph it. Okay, so f of x plus h of x. F of x is x plus 1, so it's slope-intercept form. So y-intercept of 1, slope of 1 over 1. So it would look something like this. Okay. H of x starts at the same place, and then it's minus, so we'd go minus 1 over 1, so we're going down like this. So if we add them together, what would that look like? So think about those y variables, those y values. So right here at 0, it's 1 plus 1, so it'd be up to 2, right? Then it'd be 0 for the blue, 2 for that would be right here. Okay, then negative 1 and 3 would be 2. See, I'm looking at the y values. Then negative 2 and 4. So basically, what I'm seeing here is a straight line at this positive 2. Did it work going the other way? Yeah, because we're doing the same exact thing. So combine those functions, it's a straight line. And if you wanted to double check, go x plus 1 plus negative x plus 1. What do we get? Well, positive and negative x cancel out. 1 plus 1 just gives us 2. Makes sense then. Okay, and the next one, h of x. So we've got that one again. So let me make my y-axis my x-axis. So once again, it looks like this. There's h of x. Now p of x is 2x plus 1. So we start at plus 1, but the slope this time is 2 over 1, so I go up 2 over 1, up 2 over 1. Following that pattern, or down 2 to the left 1. So how's that going to affect if we add them? Well, 1 and 1 would give us 2 again. Okay, 2 and 0 would give us 2. Wait. That would be 3 and 0 would give us 3. And then 5 and negative 1 would give us 4. 7 and negative 2 would give us 5. So we can see the pattern that would have, right? Same with this, going backwards. 2 and 0 give us, or 2 and negative 1 would give us 1. 3 and negative 3 would give us 0. So we've got a line like that, right? Because this plus this, negative 1x, 2x would give us x. 1 and 1 would give us 2, so it would be x plus 2. Which is what that orange line ends up being. Okay, now what happens when we deal with 12? This time we've got x squared. Oops, let's make it better. Y-axis. X-axis. Okay, x squared would be 0, 0. 1 squared is 1. Negative 1 squared is 1. 2 squared is 4. Negative 2 squared is 4. 3 squared would be 9. That only goes up to 8, so we'll call that good. So we've got our quadratic, right? Then we're adding to that p of x. P of x being starting at 1. Then we go up 2 to the right 1, up 2 to the right 1, up 2 to the right 1, or down 2 to the left. Okay, so let's take a look. So we'd have 0 and 1, so it would be 1. Can't see that blue very well, can you? Then we'd have 3 and 1, so 4. And then 4 and 5, which would be 9, which would be up there. Going backwards, 1 and negative 1 would give us 0. 4 and negative 3 would give us 1. So it kind of looks like that, doesn't it? Which then it would probably keep going up like this. Because if we added those together, we'd have x squared plus 2x plus 1, right? So it'd still be a quadratic. Alright, so same idea with these ones. Now we're dealing with multiplication. Now let's see, notice that we're dealing with the same functions, but instead of adding them, we're seeing how does multiplication change things. So we'll make our x and our y axes. So f of x, we know, goes like this, starts at 1, then goes up 1 like that, to the left 1 like that. Okay, so let's draw all the f of x's. Okay, oh, it wasn't quite the same on this one, was it? So we're using f of x every time this time. Okay, so there's f of x, m of x. Okay, p of x would look like that. And h of x would go in that opposite direction. So okay, so now we're thinking about multiplication. So how's that going to change things? So f of x times h of x. Well, 1 times 1 would give us 1. Okay. 2 times 0 give us 0. 2 times 0 would give us 0. 3 times negative 2 would give us negative 6. Okay, 3 times negative 2 would give us negative 6, so we can see now when we've multiplied, we've created a parabola here, a quadratic, right? Because if we went x plus 1 times negative x plus 1, we'd have negative x squared, negative reflecting over the axis. Okay, x times 1 would be 1x, negative x times 1 would be negative 1x, 1 times 1 would be 1, those would cancel, we'd be left with negative x squared plus 1. Okay, quadratic that's being reflected and bumped up 1. Okay, makes sense, see? So this one you can guess, I've got a linear and a linear, or an x times an x, we're going to end up with a quadratic again. 1 times 1 would give us 1. 2 times 1, or 3 times 2 would give us 6. Oops. So I'm taking those y values. 0 times negative 1 would be 0. Negative 1 times negative 3 would be positive 3. Okay, negative 2 times negative 5 would give us negative 10. So we just keep going up. So yep, there's our quadratic. Shift it around a bit. It's still our quadratic. So now what's going to happen when we multiply a linear and a quadratic? Well, an x and an x squared, that's going to give us a cubic, right? So 0 times 1 would be 0. 1 times 2 would be 2. 3 times 4 would be 12, so clear up here. 0 times 1 would be 0. Okay, negative 1 times 4 would be negative 4. And then, so it would look probably something like this. Okay, a quadratic shape. Or not quadratic, cubic, that's what I meant to say. Okay, so there's those ones. Alright, now simplifying. So just look for like terms and combine. 1x to the 5th, 3x to the 5th, 4x to the 5th. And remember, you always start with the biggest degree. Okay, no other x to the 4th, so 4x to the 4th. No other x cubed, so x cubed. No other x squared, so 3x squared. No other constant, so plus 3. Okay, that's all we do. 4x cubed, 1x cubed, 5x cubed, negative 4x squared, 3x squared, negative x squared, negative x, plus 6. Okay, now, even though we have parentheses, we're still just adding, so 3x squared and 1x squared, 4x squared, plus 4x minus 5, because those don't have any other buddies. Okay, 4x squared, 3x squared, 7x squared, plus 4x cubed first, minus x plus 6. Okay, now remember when we're dealing with fractions, we look for what's on the top and on the bottom. 6 and 9, that's like 3 times 2 and 3 times 3. 3 over 3 cancels, so we're left with 2. X cubed, because there's no other x's. Now there's y to the 5th and y to the 1st on the bottom, so 5 minus 1 would give us y to the 4th over 3z to the 4th. Okay, number 21. I would simplify inside here first before I square things. So that x to the negative 2 drops that x on the bottom. Okay, so we get 2. So we got x squared. Y cubed over y would give us y squared on the top. Z to the 4th over z to the 4th would cancel. So we'd be left with this. 2y squared over x squared. Then that 2 distributes. So 2 squared is 4. Y squared squared is y to the 4th. X squared squared is x to the 4th. So there's your answer. Simple as you can get it. Okay, 22. 6x plus 9. Well, you've got to think I can distribute a 3 out, right? If I pull a 3 out of that, we'd have 2x plus 3, because if I multiplied, that'd be 6x plus 9, over 3. Those 3's cancel, leaving me with 2x plus 3. Multiplying. A times a gives us a squared, plus a times b is ab, plus b times a, which is the same as ab, plus b times b, which is b squared. We can combine like terms. We get a squared plus 2ab plus b squared. Okay, 24. Take that x. X times x squared is x cubed. X times 3x, 3x squared. X times 9, 9x. Negative 3 times x squared, negative 3x squared. Negative 3 times negative 3x would be, ran out of space, didn't I? Go like this. Minus 9x, negative 3 and 9 would be negative 27. Okay, then combine like terms. We start x cubed, 3x squared, negative 3x squared, those cancel. Negative 9x, positive 9x, those cancel. Minus 27. Okay. Alright. This is 25. Same idea. We get x cubed plus 5x squared plus 25x minus 5x squared minus 25x minus 125. Okay? Those cancel, so we get x cubed minus 125. Actually, let's leave that there. 26, x times x, x cubed, x times negative x squared, x times 1, 1x. We get 1x squared minus 1x plus 1. Those cancel, we get x cubed plus 1. Okay, now 24, 25, and 26 are showing you guys a pattern. Okay, if you look at number 29, okay, x cubed minus 1, you kind of seeing, well, 26 not so much, but 24 and 25. 27 is 3 cubed. 25 is 5 cubed. Okay, this, think of it, x cubed minus 1 cubed, because 1 cubed is still 1. Okay, notice the pattern up here, and you can use that to try to figure out 29. Okay? And if you're still not sure, take a look at 28. We get a cubed plus a squared b plus ab squared minus a squared b minus ab squared minus b cubed. That would cancel with that, this would cancel with this, and you'd be left with a cubed minus b cubed. Okay, using that format, going back to this, you can figure out that. Last one, 27, we get x cubed minus 7x squared plus 49x plus 7x squared minus 49x plus 49 times 7 is what? 343, I think. Okay, those cancel, x cubed plus 343. Which 27 and 26 could tell you the pattern if it was x cubed plus 1. Alrighty, there we go, guys.